Okay, I got to figure out what type of a conic I'm dealing with, which way it's going, and then be able to set up my equation and then fill in the blanks. Okay, so the minute I see conjugate axis, I know that this has to be a hyperbola. Okay, then the next thing is if I notice these two x values, x coordinates, they're different, which means they have to be left and right from each other, which means it has to be a hyperbola that's opening left and right. Once I have that, I can start setting up my formula. I can visualize this diagram, and then I should be able to fill in all the relevant numbers, okay? Because it is opening left, right, that is saying that this is sort of like my main axis. So this has to be positive, and this has to be the negative fraction, okay? Then the next thing I need to be able to do is find the center, A and B, and I'm done. So again, anytime I give you a pair of vertices, you can figure out three pieces of information. First of all, it was opening left and right. Second of all, I should be able to figure out the center simply by doing a midpoint. So average the x's, average the y's, that's 5 and 2. So I could put my 5 here and my 2 here, and I'm actually 2/3 of the way done. And then the third piece of information that this gives me after the orientation in the center is the letter A. A by definition is the distance from the center, which I just discovered, to the vertices. So how far is 5 away from -1? That's 6. I can double check how far is 5 away from 11. It better be 6 as well. So 6 goes underneath the positive x fraction. One more, and I'm completely done. Now they tell me that the length of the conjugate axis, so that means from top to bottom, what we used to call minor vertices for ellipses, is 16, which means the semi-conjugate, which is by definition from the center to each one of these, that's B, has to equal half of that, which is 8. And that's it. Set up your equation, slowly piece together the information, and you are done.